Hello, this is Sean Murphy with Vizsla. Today we're going to go over the DL4000 Voltage Input Data Logger and explain how the device works, how it connects to analog devices, and how to set it up in viewLinc. The first thing to look at is the actual data logger itself. It comes in a small plastic enclosure, and it has 4 pins up at the top. Each one of those pins is an analog input, and you will see a DB9 serial connector on the right-hand side of the data logger. That's for use for connecting to digi devices or to serial cables. There's also a connector pin on the bottom side that's for connecting to VNet devices. Each one of the screw terminal blocks, they remove directly from the data logger on the top, and this is where you actually terminate the wires. So you'll see on here, this is a blown up image of it. Essentially, they have small terminal screws. So you're going to need to have a micro screwdriver to be able to tighten down the wires to each one of these connectors. And there's also a difference between the 2 leads. One is going to be the channel input lead. That's on the right when you're looking at it from this perspective. And the other is going to be the common lead. The common lead is typically ground with signal wiring, and the common leads are common across all the data logger inputs. Just so you know that this is not an isolated input data logger. They all share a common lead. This is showing how the data logger terminal socket plugs into the data logger itself. And this one happens to be mounted on a panel. And you'll notice that the device is lit up blue. When it's connected to a digi device, it will flash blue every time it reads. So that's just a little note about these devices. They don't do it when it's connected to a VNet. It's specific to DB9 serial cable when it communicates. And this is what the data logger brackets look like inside the CAB 100. So if you have a CAB 100 that has a mixture of voltage or current input data loggers, they come on special brackets. The details about how to disassemble and reassemble these and wire these are all part of the CAB 100 manual. We're not going to go into any details on that because there's an entire manual dedicated to the wiring and termination of CAB 100s. This page goes over the DL4000 input logger with externally powered transmitters. Now, with voltage inputs, they're always going to be externally powered because the device doesn't have like a 4 to 20 milliamp loop where it's actually capable of getting the power from the same leads that are giving you the analog output. So the 2 different models that we have are the DL4000 405. That's the model that refers to a 0 to 5 volt DC range. And then we have the DL4000 40A model, which handles the 0 to 10 volt range. And as I mentioned earlier, the C terminals on the data logger, those are all internally connected. So you could think of them as being one big bus bar across all these terminals. And each one of the ones that's labeled 1 through 4 on here, these are the actual analog inputs into the data logger. So this shows the terminals across the top and the externally powered transmitters. You'll see with the externally powered transmitters that have voltage outputs, they'll be labeled with a channel number or channel name, and they'll have a plus and a minus. So there's always polarity associated with voltage. So the negative terminal is always going to connect to the C's on the data logger, and the positive sides are always going to go to the discrete channel inputs on the data logger itself. And that's essentially how you hook up any generic transmitter. It could be an HMT 330 or an HMT 130 series. Both of those have voltage outputs as options. It could also be our PDT 101s. We have and 102s. Both of those have voltage output options as well. And you'll see the terminals either labeled as plus and minus, or sometimes you'll see the terminals on the transmitters labeled as being common and V out. The common typically refers to the ground or the negative terminal. And sometimes with transmitters, you'll have three wires for it. One for the positive for the power supply, and one for the common, and that's how the power gets into the transmitter. And on some of those units, you'll have the V out, or the voltage out, and that'll be your terminal for the connection to the input channel. So you have to really read the manual or the guidance from the transmitters themselves. There's so many different products that are out there. Just to be aware that V out is typically associated with the voltage output, which would be the 1, 2, 3, and 4 on here. And COM is typically associated with the commons, which would be all the C terminals on here. And a couple of warnings about doing analog signal wiring. One is that voltage input ranges are limited to 0 to 5 volts and 0 to 10 volts with the DL4000 series. So if you have, for example, a transmitter that actually scales wider than a 0 to 5 or 0 to 10, or for example, if you have one that actually spans from -5 to +5 volts, you're going to need to add a Zener diode across the output terminals of that transmitter to avoid running into issues where you're sending an out of range signal to the data logger and causing the data logger values to skew out of range. So overranged ones, when they go beyond the voltage limit, in other words, beyond 10 volts and beyond 5 volts, and bidirectional, which means that you have reverse voltage, like -5 to +5 volts. And never connect live DC power circuits to analog input data loggers. They're not designed to read power. For example, if you have a 24 volt power supply or 10 volt power supply, this is not designed to be a voltage meter for your power supply. So if you're monitoring DC power, you really need some other kind of device. This is not really meant to it's not designed to be able to carry a lot of current through the inputs. And in terms of setting up the device in viewLinc, essentially you go through the data logger discovery process and the installation that you would normally do with the DL4000 1416 data loggers. There's no difference in the actual installation of the data logger and the VNet or Digi device that's used to connect it to the viewLinc system. The only difference really comes in the configuration of the device itself. With a DL4000 or 1416 data logger, there's really not a lot that you need to do on it outside of maybe give the data logger a name and name the channels. With the voltage input logger, you have the device properties. By default, the data logger name is going to be logger ID, and I believe that the default sample rate is like 5 minutes on the data logger when it ships from the factory. And by default, all the channels should be enabled on it. So this is one thing you want to check, is to change the sample interval to whatever you want. It's recommended that you keep the sample interval 1 minute or longer to get the most out of the battery for your data logger. And as long as all 4 channels are enabled on the device, or there's a couple other models. It's not necessarily they're not all necessarily 4 channels. We have a 1-channel, a 2-channel version of it, but primarily we see people using 4 channels, especially in panels. The next step is going to be setting the channel properties. Both of these are when you're adding the data logger under devices in the viewLinc system. So the first thing that you're going to want to change, of course, is to give the channel a descriptive name. This is actually the name that you're putting on the data logger itself. So if you actually use vlog to connect to the data logger, you can actually read these settings from that data from vlog as well. So that's the name for the channel on the logger. You also have the opportunity when you're creating the location and mapping a location from this data logger, you have the ability to create that location name and make it whatever you want to be. It's not necessarily mapped one-to-one with the channel description on that data logger. Then you have a couple of values. Now, this is something you're not going to see on any of the other data loggers. You'll see input range. You'll see first input, second input, input units, first output, and second output, and output units. Now, what this really gets into is how the analog to digital converter operates on the data logger itself. Basically, what the data logger is doing is it's taking a continuous voltage signal that's happening inside a circuit. It's making a measurement, but it's also scaling it in terms of engineering units. So basically, in viewLinc, you're not really interested in looking at the voltage values. You're interested in, for example, looking at differential pressure values that have been encoded as a 0 to 5 signal on the transmitter. So basically, this is an example of a PDT 101 transmitter that's scaled 0 to 5 volts with a scaling output range in engineering units of minus 0.25 to 0.25 inches of water column, or INWC. If you take a look at this, the first input value, that's the 0 value of the data logger. In other words, that's the lowest measured value on the data logger is 0 volts. And the second input value is the highest level that you actually are measuring on the data logger, which is 5 volts. The input units are always going to be in volts because this is a voltage input data logger. That's it, you can't actually edit that. You'll see it; it's grayed out on here. When you get to the second set of values, it's the first output value. That's the 0 end of the scale. In other words, the lowest value from the transmitter that coincides with 0 volts, or the low end of the scale. This will be typically either printed on the calibration sheet or the data sheet, or sometimes on the instrument itself. It'll give you the DP range or the range of the instrument. With Weissel devices, we always put our ranges on the devices. The second output value is the high value, or the span. That's associated with the 5 volt reading. So basically, this is putting in an equation largely into the data logger, saying that 0 volts equals minus 0.25 inches of water column, and 5 volts is equal to plus 0.25 inches of water column. And the engineering units, the important thing about this, before you even get to this part, you're going to actually have to verify that the units exist in viewLinc. If you don't have the units for the particular analog input that you're configuring, you need to go into preferences and go into units and add those units. That's part of the setup of the viewLinc system, is to define all your units. And that's the same whether you're dealing with an analog input data logger or Modbus or any other kind of device where you're getting scaling in units that are not necessarily hard-coded into Weissel data loggers. For example, if you get an RFL data logger, all those data loggers have fixed units that already appear inside the viewLinc system, versus something like differential pressure or particle count, for example. Those units may or may not be in the list of units that you have inside your system.